Hello, my name is Lakshmi Shravanti, and I'm presenting my analysis related to the Week 6 course project of the course Machine Learning Foundations for Product Managers. Well, the ask has been to build a model that predicts the electrical energy output of a combined cycle power plant. So this data set had 9,568 records, pertaining to 5 variables, out of which 4 are feature variables and 1 target variable, that is electrical energy output. Now, the ask has been for us to, select an appropriate machine learning methodology to develop the analysis or to predict the output using one of the modeling options. That is, it could be Excel, Python, uh, or Google AutoML. So I have selected Google AutoML to, run my analysis. Now, what I have done is I have uploaded the data. Let me take you through the steps that I have done. So once I've uploaded the data, I've selected the objective as regression because as you could see earlier, all the variables were numerical and we are predicting a numerical output. So that's the reason I've selected regression, and since there are many multi-variables, I've gone for it would be obviously multivariate regression. Now what Google AutoML does is automatically it selects an appropriate model. Now I selected AutoML and I click continue. Now I've selected my target variable as P, that is electrical energy output. The Google AutoML automatically, it does the data split, and it has assigned 80% for training data, 10% for validation, and another 10% for the testing data. Now I select continue, and then I'm not adding any other extra features. So now I go for my next training options. For the first iteration, I'm using all the variables that have been given to me, all the 4 variables as my feature variables, and I'm running my analysis. Now I can also, define the time for which the Google AutoML can, train the data, and I've given us 1 node hour. What happens is if it finishes early, it can always stop, post that, and I select start training. So my first model has, came up with this output metrics where, as you can see, the RMSE is 26.9, and the MA, that is mean absolute error, is at 26.6. And this is how the feature importance has been. So if you can see, the temperature and the vacuum, exhaust vacuum, have high feature importance compared to the pressure and relative humidity. uh, uh, this is how the feature importance has been rated by the Google AutoML. And as you can see, this model has a higher RMSE 26.9 and a very high MA also, that is 26.6. That means your RMSE should be as less as possible. So what I have done is I've done another iteration. So now this time what I've selected is I've selected only 2 features as they have given high importance, that is AT and V. Now if I go for the second model, once I run the second model, as you can see, the RMSE has drastically reduced, and it has come to 3.992, and your mean absolute error is also completely down, that's 3.162, with a higher accuracy of 0.943. So I thought, with this analysis, I have selected this model due to the higher accuracy. Thank you.